Hello dear students. In this video I am going to explain about reliable data transfer over a channel with bit errors, and we will call it as RDT 2.0. A more realistic model of the underlying channel is one in which bits in a packet may be corrupted. Such bit errors typically occur in the physical components of a network as a packet is transmitted, propagate, or is buffered. Here we are using ARQ protocols, that is automatic repeat request protocols. This protocol uses both positive acknowledgements and negative acknowledgements. These two control messages allow the receiver to let the sender know what has been received correctly and what has been received in error. Fundamentally, three additional protocol capabilities are required in automatic repeat request protocols to handle the presence of bit errors. First one, error detection. First, a mechanism is needed to allow the receiver to detect when bit errors have occurred. Error detection techniques require that extra bits beyond the bits of original data to be transferred be sent from the sender to the receiver. These bits will be gathered into the packet checksum field of the RDT 2.0 data packet. Next, receiver feedback. Since the sender and receiver are typically executing on different end systems, possibly separated by thousands of miles, the only way for the sender to learn of the receiver's view of the world, that is in this case, whether or not a packet was received correctly, is for the receiver to provide explicit feedback to the sender. RDT 2.0 protocol will send acknowledgement and negative acknowledgement packets back from the receiver to the sender. In principle, these packets need only be 1 bit long. That is, a 0 value could indicate a negative acknowledgement, and a value of 1 could indicate an acknowledgement. Third one, retransmission. A packet that is received in error at the receiver will be retransmitted by the sender. Figure shows the finite state machine representation of RDT 2.0, a data transfer protocol employing error detection, positive acknowledgements, and negative acknowledgements. Sending side. This is the sending side diagram. The send side of RDT 2.0 has two states. See here in this figure, this is one state and this is another state. In the leftmost state, that is this state, the send side protocol is waiting for data to be passed down from the upper layer. See here, wait for call from above. When the RDT send data event occurs, when this event occurs, that is RDT send data, the sender will create a packet, send packet, containing the data to be sent along with the packet checksum, data and checksum, right? Then send the packet via the UDT send packet operation. Okay. After that, it changes the state from wait for call from above to next state, that is wait for acknowledgement or negative acknowledgement. In the rightmost state, that is this state, the sender protocol is waiting for an acknowledgement or a negative packet from the receiver. If an acknowledgement packet is received, that is the notation RDT receive packet and is acknowledgement received, the sender knows that most recently transmitted packet has been received correctly, and thus the protocol returns to the state of waiting for data from the upper layer. If negative acknowledgement is received, RDT receive and is negative acknowledgement, this event, the the protocol retransmits the last packet and wait for an acknowledgement or negative acknowledgement to be returned by the receiver in response to the retransmitted data packet. Okay. Here, the sender will not send a new piece of data until it is sure that the receiver has correctly received the current packet. So because of this behavior, this type of protocols are known as stop and wait protocols. Next, sending side, sorry, receiving side. This is the diagram. The receiver side FSM for RDT 2.0 has a single state. See here, wait for call from below. On packet arrival, the receiver replies with either an acknowledgement or a negative acknowledgement. That is depending on whether or not the received packet is corrupted. In figure, the notation RDT receive packet and corrupt receive packet corresponds to the event in which a packet is received and is found to be error. That is this event. RDT receive packet and corrupt packet. Then it sends the negative acknowledgement to the sender. Okay. If receiver has received a packet without any error, that is this event, RDT receive packet and not corrupt receive packet, then it extract the packet, send the data to the upper layer, and send acknowledgement to the sender. Okay. Thank you.